The first example I'm going to work is y equals 4x plus 5. And let me just write this up here. In these examples, I want to identify the slope and y-intercepts. Okay, that's what I'm doing here in these examples. So in this first example, I already have it in the slope-intercept form, okay, where M is the slope and B is the y-intercept. So if the coefficient in front of x is the slope, then I'm going to write M for slope to be 4, and the y-intercept I'm going to write as 5, and it's a positive 5, which makes a difference, right? So the y-intercept will be positive 5. I can think of the slope when I graph this as the slope could also be 4 over 1. I'm going to rise 4 and run 1. The intercept is really going to be occurring at the point 0, 5, because it's over x, right? 0 is first number is x, and up 5. Now let's look at this equation. 4x minus 3y equals 12. I want to find and identify the slope and the y-intercept, so I need to change it to be y equals mx plus b. In other words, I have to solve for y. Down here, in order to solve for y, the first thing I need to do is subtract 4x. Okay, I'm going to rewrite negative 3y is equal to, watch what I'm going to do here. I'm going to insert or shove this negative 4x right next to that equal sign. Okay, and then I'm just going to say plus 12. Now the reason I wanted to shove it right in there in front of that 12 so that it's sitting right next to the equal sign is because I want the x to be right next to my equal sign, just like it is in my equation. I want it to look just like my y equals or my slope-intercept equation. I'm not done here because I still have a coefficient in front of y. So what I need to do is divide every single term in this equation by negative 3. When I do that, I get y is equal to negative 4 divided by negative 3. In this case, I want to leave it just like it is as a fraction. A negative over a negative gives me the positive, so I'm going to leave it like that. X. And now positive 12 divided by negative 3 is a negative 4, which is where I get this negative from. Positive 12 divided by negative 3 is negative 4. So my slope-intercept equation is now y equals 4/3 x minus 4. So from this, I can find that the slope is 4 over 3, and my y-intercept occurs at negative 4. Now the reason I want to leave this as 4/3 and not 1.333 is because when I have to count the rise over the run, I can't count it if it's 1.3. I can count rise 4, run 3. Now, what do we do with the equation that looks like this? Here I have y is equal to 8. What do we know about an equation where y is equal to a value? Remember that this is a horizontal line and that the slope is 0. We talked about that in the last lecture. So if the slope is 0, if this is a horizontal line, the slope is 0, and we are crossing the y-axis at 8. So the y-intercept is 8. So this one is just a horizontal line crossing through 8. How about this over here? This line says x is equal to negative 4. What do I know about this equation? This is another unique equation. This is a vertical line. What do we know about its slope? The slope of a vertical line, or the slope of an equation where x equals a value, the slope is undefined. Remember? It's undefined. It's a vertical line. It actually never crosses the y-intercept. So it never crosses, not the y-intercept, but the y-axis, never crosses the y-axis. So there cannot be a y-intercept.